Imagine you're grading a high school math test.
Okay, sure.
Do you just glance at the bottom of the page to see if the final answer is right? Or do you actually comb through the student's scratch pad to check their work?
Well, you definitely want to see the scratch pad, right? Because if you only grade that final answer, I don't know, the outcome, you might just be rewarding a lucky guess.
Exactly. And that is the exact tension we're exploring today. We are digging through a stack of engineering docs and AI evaluation frameworks.
Right, to look at how we actually measure if an AI agent is working properly.
Because checking every single calculation, the whole process,
Yeah.
that can be incredibly tedious to do at scale.
Super tedious,
Hmm.
especially when these systems are doing thousands of operations a second.
Okay, so looking at these frameworks, it seems we have to measure agent performance along two main axes.
Yeah, that's the core of it.
Outcome versus process covers how we grade. But the docs also focus heavily on what we're grading. So end-to-end versus component.
Right, like, are we testing the whole agent system from start to finish, or are we just isolating one specific piece, like its search function?
Makes sense. It's about scope.
And the key here is treating those options like a menu, not a ladder. You don't need to build every possible test and just blindly climb to the top.
Oh, so you don't have to do all of them.
No, not at all. You just pick the ones that catch the specific failures you're actively dealing with.
But if we want to check the entire process of an agent, I'd imagine that takes forever. Like,
Well,
we can't just sit there watching the AI work in real time.
Waiting to see every database it checks? No, definitely not. Which is where a harness comes in.
A harness.
Yeah, think of it as specialized testing infrastructure. You run the agent just once, but that single run captures the final outcome alongside what engineers call the tool call trajectory.
Tool call trajectory, meaning the exact sequence of digital tools it used to find the answer.
Exactly, like which specific databases it queried or search engines it triggered.
Okay, I see.
Plus, it captures cost signals simultaneously. You capture how long the task took and how many conversational turns it burned through to get there.
Let's ground this a bit with that example from the sources.
Yeah, the hydraulic pump one.
Right. So imagine a user asks an equipment support agent a highly specific question. Like, what should I check when the hydraulic pump on a 4830 keeps tripping the overload?
A very specific real-world scenario.
Exactly. And a basic pass-fail test just looks at the outcome. Did it spit out the right part number, say 7Y2210?
Right. But with that harness capturing the tool call trajectory, we can actually look under the hood.
Check the scratch pad.
Yeah, we check the process. Did the agent actually query the repair manual for that part, or did it just hallucinate a number that happens to be right?
Wow.
And we can also check the cost. Did it navigate to the answer efficiently?
This is where a simple pass-fail grade gets genuinely dangerous, I think.
Oh, totally.
Because if the agent gives the correct part number but never actually searched the manual, it's just relying on its underlying training memory.
It just got lucky today.
Right, it got lucky today, but it's planting a massive hallucination landmine for tomorrow.
For when someone asks about a machine it hasn't memorized,
Exactly.
which is terrifying for a production system.
It is. And this leads to the golden rule of evaluating AI. Your checks need to make failures legible.
Legible,
Yeah.
meaning clear.
Right. A generic bad score just sends you on a hunting expedition.
Digging through logs blindly.
Exactly. But a score that says, hey, process passed, but outcome failed on part numbers, that tells you exactly which file to open and fix.
But what if the whole thing is just inexplicably broken? Like, you run your end-to-end test and it just fails across the board.
It happens.
Because tweaking the agent's prompt at that point feels like, I don't know, putting a Band-Aid on a broken leg.
It really is, and that's exactly when you switch from end-to-end testing to component testing. Isolate the noisiest part.
Okay, so zoom in.
Yeah. Take the AI model completely out of the loop and run 20 queries directly through your manual retrieval system.
Just the search part. Right. If the retrieval itself is fundamentally broken, the agent never stood a chance anyway.
The big takeaway here seems surprisingly practical, actually. Don't rush out and try to write 50 different checks for your agent.
Please don't. Pick the 2 or 3 failures you would be absolutely most embarrassed to ship to a customer.
The absolute worst-case scenarios.
Yeah. Write a check for each of those and just run them on every single change you make to the system.
Start small, cover your worst bases. It does make you wonder, though, right?
About what?
Well, as these AI agents become more autonomous and start writing their own tools, will human evaluators even be able to read their scratch pads anymore?
That is the big question.
Or will their process become a total black box that we just have to blindly trust? Something for you to think about.